Class, welcome to Introduction of DSP Part 2. In the last class, we have already discussed few topics such as what is a signal, what are the major classifications of signals, then why are we processing a signal, what is the requirement of signal processing, the basic build block of a digital signal processing system. Now in this class we will talk about some advantages and limitations of a digital signal processing or a digital signal processor. To start with, the first advantage is greater accuracy. Now analog components or an analog processor is less accurate compared to its digital signal counterpart, a digital counterpart of the analog processor, because of the component tolerance. The tolerance of the circuit components used to design an analog filter, for example, a resistor, inductor, capacitor, or other active components, will give it a lesser accuracy compared to its digital counterpart. And also, the digital signal processor will be less susceptible to environmental damages or environmental changes compared to analog processors. Analog processors or analog components are much more susceptible to environmental damages. For example, change of temperature will have a change in the or rise in the heat, and change in heat or rise in heat will have an effect on the analog components. So the accuracy gets hampered. So digital signal processors will be much more accurate compared to its analog counterpart. Now the second point is cheaper. In many applications, it has been seen that digital realization is comparatively cheaper than its analog counterpart. The third point is ease of data storage. Of course, a digital signal can be easily stored on a digital platform. It can be on a magnetic media without loss of fidelity and can be processed offline in any remote laboratory. That is, data storage is much more easier for a digital signal as compared to an analog signal. Number 4 is implementation of sophisticated algorithms. As we proceed further with this subject, we will come across few algorithms which are used by a digital signal processor. Now, the DSP allows to implement sophisticated algorithms which is not possible in its analog counterpart. We will study few algorithms later. Now, the fifth point, as I have mentioned, is flexibility in configuration. See, a DSP or a digital signal processor usually deals with numbers. So, it can be easily reconfigured by changing the program or changing the numbers in the program. You do not need a complex reconfiguration of an analog system which involves redesigning of the total system hardware. We do not need to change for an error. We do not need to rectify an error. We do not need to change the whole system hardware in case of an analog system, which we have to do. We do not have to do that in case of a digital signal processor. Only changing the program or only changing few numbers will help us remove the error. So it is very much flexible in configuration. A digital signal processor is far flexible in configuration compared to its analog counterpart. Now, the sixth point is applicability of VLF signals or very low frequency signals, such as say seismic the signals which occur in seismic application, or we can talk about this point in a different manner also, or we can say that a digital signal processor can be configured or is integrable in a chip. Why? For an analog processing system where inductors and capacitors are needed, it would be a bulk, or you can say where a transformer can be needed, it will be a bulky proposition. It would be physically very large in size so that it cannot be put into a integrated chip. We cannot make an analog processor, or making an analog processor into a chip is difficult compared to a digital signal processors which can be put into a or which can be integrable into a IC, integrated chip. Number 7 is time sharing. Now, DSP allows the sharing of a given processor among a number of signals by time sharing, thus reducing the cost of processing a signal. Now, if we move to the disadvantages or limitations, first limitation that comes to our mind is system complexity. See, for an analog processor, if we go back to the digital signal processing system, the block diagram that I have given you, for a DSP, or you can say to process a digital signal where we are using a digital signal processor, we will be needing more blocks, that is analog to digital converter, then again digital to analog converter, sample and hold, anti-aliasing. All these blocks or all these systems come into existence because we are using a digital signal processor to process and even analog signals. So that means what? It is increasing the system complexity. Number of blocks are increased, so complexity is increased. The second point is bandwidth limitation by sampling rate. Now, signals having extremely wide bandwidths require fast sampling rate. Now, analog to digital converters and digital signal processors has to be very fast and has to have fast sampling rate. But in practical world, there is a limitation in speed of operation of analog to digital converters and digital signal processors. So this becomes a disadvantage or limitation of the digital signal processor. Now, power consumption. A variety of analog processing algorithms can be implemented using passive circuit elements like inductors, capacitors, and resistors that do not need much power. But as I told you, DSP chips which contain, I have told you DSP or a digital signal processor can be put into a chip which can contain lakhs and lakhs of transistors which can dissipate more power compared to its analog counterpart. Now, moving to the applications of DSP. The applications of DSP are many. To name a few, we have the telecommunication field, electronics field, instrumentation and control. For example, in instrumentation and control, we have digital filters, PLL, then servo control, robot control, process control. Now, DSP is also used in image processing, that is in image compression, image enhancement, image analysis and recognition. Then we have medicine. In the field of medicine also, we need DSP. For example, spectral analysis of ECG and EEG signals to detect the various disorders in heart and brain all need digital signal processing. Then speech processing, seismology, military. It is in military. It is very interesting. For example, radar signal processing, sonar signal processing, navigation. We will study the use of DSP. For example, when we study DFT, how DFT is included in, or how DSP, application of DSP in military field, we will study that when we study DFT. So these are some of the applications of DSP. So in the next class, we will be moving into the chapter of DFT, and we will see how DFT, that is discrete Fourier transform, is different from DTFT, that is discrete time Fourier transform, that we have already studied in signals and systems. Thank you, class.